Okay, thank you for your patience. We're going to start this presentation welcoming Haseeb back to the stage. He's going to talk about ENS and IPFS, two awesome things that combined are even more incredible.
Thanks, Ken. So yeah, let's get started with ENS, which stands for Ethereum Name Service. Can I get the screen back? Sweet. Okay. So I'm actually going to cover IPFS first, and then we'll try to see how we can use IPFS with ENS. Right? So what is IPFS? So IPFS describes itself as an open source, peer-to-peer, hypermedia distribution protocol, right? And that can be a mouthful, right? So a simpler way to put it is that it is just a peer-to-peer, it's peer-to-peer file sharing, right? Peer-to-peer storage. Yeah, it's peer-to-peer storage, and it's not just for any file, right? It's not just for like your photos or your MP3s. It's actually for all files on the internet, all files on the web. Are sort of like that's the goal behind IPFS, to provide a decentralized, distributed storage layer for the web. And this project isn't actually directly part of the Ethereum project. It's a separate standalone project, but it plays very nicely with blockchains, and we'll see how it does that in a second. To use IPFS, it's really simple. You just upload a file to IPFS, and IPFS will give you back a hash. And this hash, this IPFS hash, serves as a unique identifier for your file globally. Right? So if anyone else around the world were to upload that exact same file to IPFS, they would get the exact same hash. That's one of the properties of IPFS, that it sort of uniquely identifies a specific version of a file, right? But if I modify that file, then the hash will change, right? Then the IPFS hash will change, and I'll have to re-upload that changed file to get the new hash. So that's how IPFS works in a nutshell. And the purpose of IPFS is to replace HTTP, right? So right now, when we download a file over HTTP, we're usually connecting to one central server, and we download one file at a time, right? And what IPFS is saying, hey, don't just connect to one server, right? If there are peers around you who are closer to you who have that file, you can actually get that file or parts of that file from multiple peers, right? So it kind of becomes like almost like a torrent. Like you're receiving parts of the file from different peers in the network instead of connecting to only one central server to download the file. So that's kind of the idea behind IPFS, and it's actually trying to replace HTTP. There are some other inefficiencies with HTTP that is covered on the IPFS website, but I'm not going to go into details on that here. I encourage you to check out their website at ipfs.io. Check out their documentation, examples, lots of great knowledge on their website. And yeah, like I said, it can be used with blockchains like Ethereum. So if you're familiar with Ethereum, you may know that storage is actually kind of expensive, right? And you can't actually store large files on the blockchain because of how expensive it is. So IPFS is sort of like this complementary technology that you can store your large files on, and you would only have to store the IPFS hash on the blockchain. Right? So that kind of becomes a way to reference a file that lives off the blockchain, but the hash guarantees that the file hasn't changed, right? As long as the hash is the same, the file is the same. So that's kind of how they would interoperate with each other. And I'm just going to show you quick demos of how to use IPFS. So to install it, you go to ipfs.io, and just click on the Install tab. I'm not going to do that right now, but yeah, you just download a simple installer and install it to your machine. And then we can use it on the command line. I'm just going to move this over. Zoom in a bit. Okay. So once you have IPFS installed, right, you can check real quick that you have it by just checking your IPFS version. All right, so it's installed and it's working. And the first thing you have to do is initialize your IPFS local repository, right? And you do that really easily by just saying IPFS init. My repo is already initialized, so it's going to complain saying, hey, you already have a configuration file, and you shouldn't overwrite it, right? And so it creates this IPFS cache or local repo in your home folder, right? So that .ipfs folder is going to store my IPFS files that I request from IPFS. And another thing that IPFS init does is it generates a what's called a peer identity, right? Which is just a key pair that identifies you on the IPFS network, right? Just like Ethereum, you have a key pair that identifies you on the network. With IPFS init, you get a separate key pair to identify you on the IPFS network. And yeah, if you want to see more available commands, just IPFS help. We're going to look at a few simple commands. There's quite a bit over here, but we're just going to look at some simple stuff. So let's try uploading a file to IPFS first, and I'll try to use the same file as I did in one of my earlier workshops. Right, and I can see that I have 3 files in this folder. One is my key file, one is my HTML file, and another is a Ethers slug that I was using to deploy. But let's try and upload this index.html to IPFS. So we would just say IPFS add index.html. All right, let's run this. Awesome, so it added it to the IPFS network, and it generated this IPFS hash that uniquely identifies this index.html file, right? So as an example to see how the hash changes, I'm just going to change one character in index.html, and then we'll try to add the file again. Yeah, I'm going to show that in a second, yeah. Right, and all I'm going to insert is 1 space, right? That's all I did. I'm going to save the file, right? And now if I try to say IPFS add index.html again, it gave me a different hash, right? So it's kind of like a version timestamp for the file, right? So we can refer to specific versions of this index.html, and we can sort of create like a history using these IPFS hashes, right, where we can keep track of that history of the changes to that file, right? And if anyone else in the world were to upload that exact same index.html, they would get the exact same IPFS hash, right? So IPFS would just detect that, hey, this file already exists on my network, and oh, here's the hash. So it wouldn't have to re-upload it again because it's already there. So that's a simple add. Now, once you have the hash, right, once you've added it to the IPFS network, we can then run some other commands on it, right? Like we can view a specific IPFS hash by typing IPFS cat and then the hash of the file, right? And it will print out the HTML that we had, that I wrote earlier on, and we can see that it has the space as well. So IPFS cat only works for files, right? So if this was if this hash referred to a folder, IPFS cat wouldn't work, right? I would have to use a different command. Let me bring this up a bit. So if my hash was a folder, I would just do IPFS ls and then the hash. So that hash isn't actually a folder, so I'm not going to do that. Okay, let's try uploading this folder now, right? So you want to recursively upload this particular folder that I'm in right now. Let's see what that would look like. I'm just going to remove my account.json file for now. You probably should be more careful doing this, but I'm just doing it off the cuff. So, okay, let's say I wanted to upload this entire block explorer folder to IPFS, right? So I would still say IPFS add, but I would just pass this R option to tell it to recursively add the files in this folder. And I just say dot. And we can see that it added, so it added the slug file, and then it created an IPFS hash for it. It added the index.html, and it's the same hash as we saw before. And it also added a entry for the directory itself, right? So I can take this IPFS hash that references my folder and say IPFS cat. Oh, sorry, not cat, because it's not a file. We have to use ls. And it'll print out the contents of that folder for me. Okay, so that's some basic usage of IPFS. You can upload a file, and you can view an IPFS hash in your terminal. But what if you want to actually view the file itself, like in a browser or something, right? Like, let's see how we would do that. So let's say I want to view this index.html in a browser. So what I would do is open up my browser, and there is a main sort of, it's called a public gateway for IPFS at ipfs.io/IPFS. And if we just paste in the hash, the text is kind of small, but I just typed in ipfs.io/IPFS/the hash, right? And if I click enter, inside the where, sorry? Oh. Yeah, this text is a little hard to read. Okay, there we go. Let's try that again. And so the first time we load up a file from IPFS is going to take some time, because what's happening is we uploaded that file and it has to propagate through the network, right? So now that I've requested it from the public gateway on ipfs.io, it's gonna look around its network and see who actually has this file. And since I'm the only person that has this file, it's gonna have to connect to me to get that file. But okay, so since this will take a few minutes, what you can actually do to make it appear quicker is run an IPFS node locally, right? And you can do that through the terminal. So while we wait for this to load, so back in the terminal, we can say IPFS daemon, right? And this will start up an IPFS node running locally. And it's running on port 8081. I think I changed the default. The default is 8080. But yeah, I changed it to 8081, right? So if I go to my browser, and this one is still loading, and I type localhost 8081/IPFS/ what happened there? Yeah, I felt like I heard something turn off as well. I felt like I heard like a thud or something. No, I don't believe it will. It will be unique. Yeah, it's not relative to the directory that it's in. Yeah. Yeah, because like in the example that I saw, like when we uploaded the HTML file individually, it gave me the same hash as when I uploaded the whole file. Yeah. Yeah, so you can, so the reason why it's taking so long is because not a lot of nodes in the network know about this hash right now, right? But you could precede, like you said, right? You could sort of, set up your own nodes, right, that will provide this file to other users of your network, right? So that's another way to get a faster load time from the network than just going through the public gateway. That's an interesting question. I imagine it would take the contents of the folder into consideration when it's calculating that hash. Yeah. The privacy and security features. I mean, this is just for like public file sharing, right? The security features you could build by integrating it with Ethereum, for instance, right? So you don't actually give someone the file hash, or you hold back the file hash from them until whatever they make a payment or something. But IPFS itself doesn't. I don't believe it provides encryption. I could be wrong about that. They could have encryption, but I don't think they do. It won't find it. It won't find it. Yeah, because if you were the only person with that file, then yeah, like it won't be able to find it. No, like the hash is public. Yeah, if you have the hash, you can access the file. Yeah. No, so this is only the first time, right? So because this was the first time we loaded it through the public gateway, right? It's gonna take some time for it to propagate through the network. But the second time we go, it'll be like snappy. Like what's the? For a faster payload time, you would have to do something like preceding, where you create your own IPFS nodes that already have that file, right? All the files that you want to distribute, and then as other people request that file, they'll get copies of it too. Yeah. Right. When they request it, you store a copy of it. Yeah, and then you can be the sender to someone else that wants that file. Yeah. It resulted in a collision. Yeah, I mean it's possible, but like highly improbable, right? Just given the size of the hash. But yeah, it's the same with like Ethereum, right? Like you could generate an Ethereum account, and right, like it could be someone already has that account, right? Yeah. Okay, it looks like we're having some screen difficulties here. Yep. No, so you don't have to pay. So there's no payment involved in this, right? Like this is like you can run your own IPFS node. IPFS itself also tries to run nodes for the community, but it's a community project, right? Like so you can come and also set up your own IPFS nodes, and that will strengthen the speed of the network, the speed at which files can be propagated, because they're more likely to be available at different nodes. So, yeah. How do they choose which ones to host? Like which files to host? Well, Do they choose which block? I'm not sure about that. I'm not sure about that. Can you remove files? Files can be forgotten, but once it's on there, it's on there. Like you can't say, hey, remove this file. Not to my knowledge, you can't remove it. Yeah, because you don't know who else has a copy of it, right? So you can't be like, hey, remove it. Like, yeah. Oh, cool. Yeah, we should have the screen back up shortly. To forget a file, it just means that like not enough people requested it. They didn't have copies of it. And let's say like you were running a node and you had the only copy of that file, and you you couldn't afford to run the node anymore. Then that file is forgotten. Yeah.
Are we good to simply have him say, hey, if you have any more questions about IPFS, come talk to him over there and he can try to answer this?
Absolutely.
Okay.
Go ahead.
Okay, so those were the basic usages of IPFS that I wanted to show you. If you have more questions or you want to learn more about ENS or IPFS, just come talk to me off stage and we can help you out. Thank you.
Okay, so one thing that was kind of sad just happened, as you can tell. We had someone try to plug in to an outlet over there. It tripped a breaker. I don't really know what that means, but it exploded. And that meant that we've lost power to things over there that may have made us lost power over here. So we are trying to get the screen back on by connecting to a different power source or something. These are the trials and tribulations of this 1920s car showroom. So that is the sad news, but we got Tim here working on it, and we'll see what happens. The other news is, I think, so we just had Comcast here for a very extended period of time, plus our Wi-Fi internet team working. People should try the internet right now, and give me a raise in your hand. Who has internet? Okay, we're kind of getting closer. Does it feel better than in the past? Yeah, okay. So I think we should have internet back. So that's good news. Yay! But we still definitely have that sad news here. In theory, Elena is going to talk about non-fungible tokens and ERC 721 and CryptoKitties-like things in a bit, but she has a very visual presentation, so we'll kind of keep you updated on that and either be going in 5 minutes or be going in something like 15. So thank you again for your patience.